This is MA 259, section 7.1, now with a practice set problem number 7. So here we have a piecewise function situation. So this is the picture that we're given in our book, and we can see that there is the solid line starting at 0, but starting at 1, but not including 1, and the output is 0. And then from 0 including 0 to 1 including 1, we have this output of 1. So we have this discontinuous thing, but it's still piecewise put together. So what I'm curious about is, how do I find the Laplace transform of this thing? So I wrote this as a piecewise function. F of t equals 0 if t is bigger than 1. So t is bigger than 1, we got 0. And 1 if t is less than or equal to 1. So 1 if t is less than or equal to 1. Now, one of the things you might ask is, what do I do about before t equals 0? Well, technically speaking, I could add a little extra here. I could say that t is between 0 and 1, including 0 and including 1. But remember, the definition of our Laplace transform says when t is bigger than 0. So Laplace transform has that condition that t has to be bigger or equal to 0 to start with. So we don't worry about writing that part here because of that condition that's given to us in the actual definition of the Laplace transform in the first place. Okay, so what I do then to find the Laplace transform is I write this script L with a bracket of f of t, and I'm going to integrate not from 0 to infinity like I've done before, but only from 0 to 1. Well, and why only from 0 to 1? Well, I know it's kind of silly, but at first you have to think about it. Well, I'm only integrating from 0 to 1 because that's from 0 to 1, right? This is the thing I'm interested in. Beyond 1, I would have e to the minus st times 0. So I'd be integrating 0, right? And that's trivial. So really I'm only integrating from 0 to 1, e to the minus ft st times f of t dt. And when I'm using the f of t function on the bounds from 0 to 1, then I'm going to use 1. So I do from 0 to 1, e to the minus st times 1 dt. And when I evaluate that, I get this e to the minus st divided by negative s, evaluated from 0 to 1. And so I plug in the 1 where I see t, and I get e to the minus s, and then divided by minus s, and I get minus e to the 0 divided by minus s, because I plugged in 0 where I saw t, and this negative from the fundamental theorem of calculus. And when I simplify, I get 1 minus e to the minus s divided by s. Okay, let's look at number 10. Same idea, except for our function in number 10 is a little more complicated than it was in number 7. In number 10, we are faced with this line from input 0, output 1, to the point 1 comma 0, so this line going down, which is 1 minus t. So this is 1 minus t. And so then starting at 1 and going on to infinity, I have 0. So I wrote this piecewise function, 0 if t is bigger than 1. So 0 if t is bigger than 1. And I have the situation of 1 minus t if t is less than or equal to 1. Less than or equal to 1. Now once again, I could put here that t is between 0, including 0, and 1. I could write that in this part. But the definition of the Laplace transform says t only bigger than or equal to 0. So I don't really need to put that part. So the Laplace transform of f of t, so I make this capital script L in the brackets and then the f of t on the inside, is from 0 to 1, e to the minus st times f of t dt. And in this case, from 0 to 1, my piecewise definition is 1 minus t. And I'll have to admit, when I first worked this problem out to make the video, I accidentally wrote t minus 1. And then all of these things had the opposite sign that I needed. And I got all the way done, and I said, wow, that doesn't look right. And I went back and I realized that I had interchanged this, and it should be t minus 1 is what I had written, and it should be 1 minus t. So I had to go back and write 1 minus t, and then I wrote a negative and a positive, and so that's why you see all these strange looking positives, because I had made the negative sign into positives when I fixed it. So I work out all the Calc 2 stuff, and when I'm finished, I get e to the negative s plus s minus 1 all divided by s squared.